Welcome to my channel once again. This is Teacher Tare. In our previous lesson, we discussed chemical combination. In today's topic, we'll be talking about oxidation-reduction reaction. So these two, let's come together. This is oxidation, this is reduction. So these two reactions occurs in an opposing way, but both are complementary. That is to say, this when a given reaction is taking place, two of them go simultaneously. So in this aspect, we define oxidation states as a loss of electron, while reduction reaction is that reaction that accepts this electron. So for this reaction to take place, there must be an electron donor and an electron acceptor. That is to say that oxidation reaction is also known as transfer of electron. It's a process through which electron is being transferred. So the other name of this oxidation-reduction reactions is known as redox reaction. It's known as redox reaction. So in this regard, for us to understand this concept known as redox reaction, we must know what is known as oxidation number. So we must have a very solid foundation about this oxidation number of elements in a compound. That is to say, we are going to dive into what is known as oxidation number and the rules guiding this oxidation number in element. So we are moving directly to rules guiding oxidation number. Let's say oxidation number. So one of the important rules in oxidation number is that any free element, every uncombined element in the world, the oxidation number that is assigned to it is zero. That is to say, every free element like hydrogen, lithium, calcium, beryllium, boron, and so on and so forth, all the elements in the periodic table per se, the oxidation number assigned to them is equal to 0 because they are all combined. So, the other rule is that the sum of a neutral compound, the sum of the oxidation number of its neutral atom or neutral compound is 0. Is 0 as well. Is 0. That is to say, the sum of oxidation number of any compound is equal to 0. It's equal to 0. So, for instance, we have SO4 is equals to 0. All compound, all neutral compound is equals to 0. That is to say, if peradventure you are asked to look for any of these oxidation number of this carbon or oxygen in this compound, we must equate the sum of this oxidation number of this compound to equal to 0. So make use of this aspect in due course. So the other rule is that the sodium, magnesium, aluminum, calcium, they are all metal. That is to say, from group 1, 2, 3, they are all metals. So we indicate these metals with a positive charge. That is to say, that is why you have calcium plus 2 plus. That is why you have magnesium 2 plus. That is, every non-metal is indicated with a negative charge. Let's say the group 7 element like chlorine is indicated with a univalent charge that it needed only 1 electron. It can accept only an electron. So by so doing, we understand that the characteristics of metals is that they donate this electron to become positively charged ions. So in this aspect, in non-metal, the major characteristics of non-metal, they accept electron. That is to say, in due course, we understand what is known as oxidizing agent and a reducing agent. By so doing, we said the oxidation number of oxygen, in compound is -2, but in peroxide, like H2O2, the oxidation number of oxygen in this regard is -2. Is negative 1, pardon. It's negative 1. So there is still an exception. We have oxidation number of hydrogen. Oxidation number of hydrogen in compounds is +1. But in hydrides, like sodium hydride, the oxidation number of hydrogen here is -1. That is to say, these are the rules guiding this oxidation number of element in a compound. So, for instance, now you are asked to look for oxidation number of a central element in a compound. For instance, let's use this as a very good example. Let's use a very good example. Let's use, we said the sum of a oxidation number of a compound is equal to 0. That is to say, we know that this is carbon oxide. Since carbon exists in two states of 2 and 4, we should be able to know the state at which this carbon is reacting with oxygen. That is to say, we know that this is carbon oxide. As a chemist, if I should say I'm using carbon oxide, I will be asked which of the carbon oxide am I using in my experiment. By so doing, they are asking me to state the state at which this carbon is reacting with oxygen. So in this now, we said carbon here that we know the oxidation state, we said is S, we said plus oxidation state of oxygen is -2 that I've mentioned before in a compound. We equate it to 0. We have oxygen occur 2 times. We write the 2 here. We said 2 times -2. We said S equals to -4. It's equals to 0. We said S is equals to +4. That is to say, this is carbon. This is carbon 4 oxide. So in this aspect, any compound or any element that exists in two forms, that is to say, it has 2 or more than 1 oxidation state, we use these rules to indicate the state at which this carbon is. For instance, we use a Roman figure enclosed in a bracket to indicate the state at which this compound, this element is. For instance, let's use carbon 2. For instance, carbon 2, we say we equate this compound is equals to 0. We said S plus -2 is equals to 0. We said S minus 2 is equals to 0. We said S is equals to +4 plus 2. This is to say, this is carbon 2 oxide. But they are both carbon oxide, but with the help of oxidation number and the knowledge of oxidation number, we are able to state the state at which this carbon reacted with oxygen. With a better knowledge of this oxidation state, the oxidation-reduction reaction will be very, very easy, because for a redox reaction to take place, there must be transfer of electron, there must be change of electron. So by so doing, we must calculate the differences in oxidation number of when they started and the product that is formed. By so doing, we can know when a given reaction is a redox reaction or not. So this, with a better understanding of this oxidation number, we are going to move directly to the oxidation-reduction reaction for our day topic today. We said oxidation-reduction reaction is known as redox reaction. It's known as redox reaction. And this involves the transfer of electron from a donor, which is known as a reducing agent. A donor of electron known as a reducing agent, said donor of an electron. So this concept, these keywords we are trying to explain, please pay very good attention so that we will not be confused when comparing these the reactants that are known as reducing agent and the one that are known as oxidizing agent. So we said a oxidation-reduction reaction is a redox reaction. A redox reaction involves the transfer of electron from a donor, which is known as a reducing agent, to an oxidizing agent, which is known as acceptor of electron, oxidizing agent. By so doing, we said this is what? Electron acceptor. So this is what we have, that oxidizing agent is known as what? Electron acceptor. That is, in our basic knowledge of the characteristics of non-metals, in most cases, non-metals, they are electron acceptors. While metals, they what? They do donate electron. For like group 1 and group 7 element, like sodium and chlorine, sodium donate this 1 electron to chlorine to become octet structure, to achieve this one, a state known as octet structure, like I've explained in a combination of compounds. That is to say, having known this, we are going to dive into a more point in this lesson. So how can we identify oxidizing agent and a reducing agent? A reducing agent in a chemical reaction. Please take note of this point. How can we identify oxidizing agent and reducing agent in a chemical reaction? That is to say, we said a reducing agent is the donor of an electron. So when oxidizing agent is what? Is the acceptor of this electron. So we said oxidation-reduction reaction is an opposing reaction, but they are complementary. So when one is donating, there is one there to receive this electron. So in this aspect, we say one of the points we are going to identify is that if there's any change of oxidation state of any of the reactant, for instance, let's have a hypothetical reaction, B to give C plus D, for instance. If there is a change in this, let's say let's say we have B, we have AC plus BD, for instance. If there's a change, if we have here that oxidation state of this reactant is +2 here, and it moves down, and you got here that this oxidation state of A here is 0, for instance, that is, it moved from 2 to 0. In this case, this oxidation state of this A reduces. So in this aspect, we say this is reduced. So if in this case, if the oxidation state of this B in this phase is, let's say, is -2, and it moved down to here, that here we said oxidation state of B here is +4, that means this increases simultaneously. That is -2 to 4, that is increases. In this case, any substances or the reactant that increases the oxidation state, it means this system have oxidized. So any oxidized reaction, when a oxidation number is oxidized, this aspect is known as reducing agent. B is known as reducing agent, while this is known as oxidizing agent. That is to say, from this, let's use from this to this, it undergo what is known as oxidation. While this, from A to this, since it's oxidizing, it undergo what is known as reduction reaction. With this knowledge, we are going to introduce a simple equation so that we can identify the oxidizing agent and a reducing agent. With the idea of this oxidizing and reducing agent, we'll be able to identify when a reaction is redox or not. So let's use a very good example. Let's use a very good example to explain this concept. Let's use carbon plus zinc oxide to give carbon O2 plus zinc. So in this aspect, if you should check this, let's say we have 2 here. Let's just balance the equation. We have 2 here. That is to say, if we should have an equation like this, look at what concerns. Let me bring out a point. When you're looking for the oxidizing and reducing agent, be very, very concise with this part of this equation, which is known as a reactant. So in this aspect, you can see here that the oxidation state of carbon here, according to arbitrary rule of oxidation number, any free element oxidation state is 0. That is 0. The oxidation state of carbon here is 0. That is to say, let's check the oxidation state of oxygen here, of a carbon here. That is what it means. We said carbon O2, the sum of oxidation number of this compound is equals to 0. We said S, since we don't know the oxidation state of carbon, we'll take it to be S plus oxidation state of oxygen is -2 times 2 is equals to 0. S, -2 times 2 is -4 is equals to 0. S is equals to +4. That is, in this now, this carbon moved from 0 to +4. Okay, let's check zinc here. The oxidation state of zinc is +2 here. From here, we can infer if the oxidation state of zinc, it moved from 2 +2 to here, the oxidation state of a free element, as I've said, is equals to 0. Here, we say here is 0. Since this moved from a 0 to +4, there's an increase in oxidation number. Such case, this is known as, it has been oxidized. Carbon has oxidized. We said zinc moved from +2 to 0. This is reduced. In this aspect, this means it is reduced in the process. So what happened here? An oxidized part of a chemical equation is considered as the reducing agent. Is considered as a what? As a reducing agent. While the part that is oxidized, that is reduced in the process, is known as what? Oxidizing agent. Or shortened to be OA. Reducing agent is shortened to be RA. So by so doing, in this aspect, we can in some of the textbooks, you notice that from here we set carbon. Let's draw an arrow from here to this place. Since it's a reducing agent, it will undergo what is known as oxidation reaction. So in this aspect, from zinc here to this, since it is reduced in the process, is undergo what is known as what? Reduction reaction. So what do we have here? We said any part that is oxidized is a reducing agent. So any side that is reduced is known as oxidizing agent. From this to this is known as what? Oxidation reaction. So from this to this, we have reduction reaction. So let's take a very good example again. If this is clear, when it is oxidized, it's reducing agent. It's known as the reducing agent. When it is reduced, it is known as what? Oxidizing agent. So by so doing, this is RA, this is OA. So once it moves from here, it's a reducing agent, it undergo what is known as oxidation reaction. So by so doing, here it moves here directly to this known as what? Reduction reaction. So let's take another example. Let's take another example. Let's use a very familiar, let's use iron chloride plus chlorine gas, for instance, to give ion Cl3, 6Cl, 6, we have 2, yeah, it's balanced. So how can we identify the reducing and oxidizing agent here? So in this aspect, let's use this. We said the oxidation state, as I've said before, we are concerned about this reactant part. About this reactant, we have here, what is the oxidation state of ion here? So the oxidation state of chlorine here automatically as a free element, it is known as what? It is 0. It's 0. So we know this is ion. We don't know the oxidation state of ion. Ion exists in two forms, +2 and +3. Here, let's use S to represent S. We know the oxidation state of chlorine in solution is chloride -1 is equals to 0. Since you occur 2 times, I'm going to say multiply times 2 is equals to 0. So by so doing, we said S -1 times 2 is -2 is equals to 0. From here, we said S is equals to +2. That is, here ion here is +2. So we'll come to this place. What is the oxidation state of this? We said we're going to say FCl3 is equals to 0. By so doing, we said S plus -1 of chloride is equals to 0. We said 3 times -1. I'm going to say S minus -3 is equals to 0. S is equals to what? +3. We can say here that ion moved from +2 to +3. While chlorine from reactant move from, let's use chlorine, move from 0, oxidation state of 0, because it's a free element. According to the first law of oxidation number, the oxidation number of any free element is equals to 0. But here, it is oxidation state of chlorine here is -1 times 3. That is -3. So we move from 0 to -3. So some students might actually have problem here. 0 is bigger than this -3. In this aspect, if you are plotting a graph, say we have 2 lines, say we have x-axis and y-axis and x-axis. We say this is an origin. We say this is a positive y. This is positive negative y. This is negative s. This is what? Positive s. In this, you will see 0 here before you have -1, -2, -3. That is, you cross here before you get to 0. So 0 is bigger than what? Than -3. That is to say that chlorine is being reduced. Chlorine is reduced. So this is oxidized, move from +2, because oxidation state increases, it's known as oxidized. So an oxidized part of this reaction is known as a reducing agent. A reducing agent. So why this part here is known as what? Oxidizing agent. So by so doing, we said here, from here to this, undergo what is known as oxidation reaction. Why this to here, undergo what is known as reduction reaction. So with this concept, in this concept, let's bear in mind that this is the very foundation of oxidation-reduction reaction. We are going to end here. In our next videos, we'll be talking more about complex oxidation numbers, and we spoke about how to identify an equation with a complex equation, so that you'll be able to identify this in your JAMB exam, in your NECO exam, and your WAEC. So please do well to subscribe to this channel. Thank you.